This is a woman in labour, and she's breathing gas and air from a cylinder, which looks really simple, but if you think about it, this cylinder is at 137 bar. That's 137 atmospheres of pressure. So if we just connect the tube to the cylinder, it's just going to blow our lungs apart. So we need something in here called a pressure reducing valve. And that pressure reducing valve is going to do exactly what it says on the tin. It's going to take the pressure inside the cylinder and reduce it down to a safe level that the woman can breathe without damaging her lungs. So how does that work? As we mentioned in our previous video, we're going to use a very simple equation. Pressure is force over area. And what we're going to do is just move that around and say that area times pressure is force. And we're going to use this principle to build a pressure reducing valve. So in building our pressure reducing valve, we're going to start with a really simple 2-chambered box connected by this tiny little hole. And this side connects to the cylinder, and this side connects to the patient. The crucial component of this pressure reducing valve is a large diaphragm here, connected by a rod to a really small plug here. And that is then connected with a spring to the wall of the box, and that spring is pushing down. And that is the whole mechanism, and we'll explain how it works. So I've drawn the schematic a bit bigger to make it clearer. So these are the two states the valve can be in. It can be closed, where the little plug is covering the little hole, and it can be open, where this diaphragm is bent down and the plug has been pushed down, and this allows gas to escape into here. And we'll explain how it works. We'll start in the closed state. Let's assume that we've got our cylinder attached here, and this chamber is full of our nitrous oxide and oxygen, our NTNOx or gas and air, and this chamber is also full of it. This spring is pushing down against the diaphragm, and the gas is exerting a pressure on the walls of the container here. And this pressure is force over area. In this chamber here, the gas is at a certain pressure and it is applying a force to the walls of the chamber it is contained within. Now we've already said that the force is the pressure times the area. So if we give the gas a really big area to apply force to, the bigger the area, the larger the force it's going to apply for any given pressure, which means to achieve a large force, we don't need much pressure if we've got a big area. And that is how this whole mechanism works. We've given the gas a large area to work with, and so it doesn't need to be at very high pressure in order to apply enough force to counteract the spring. If the patient takes a breath of the NTNOx and reduces the pressure in here, then at some point the pressure will drop to a point where the force is no longer big enough to overcome the spring. So the spring pushes down, pushes this stick, pushes the plug away from the hole that was keeping that hole closed, and all of this gas can then escape into this chamber to replace the gas that's just been inhaled by the patient. Now at some point, the pressure in here is going to build up because it's now directly communicating with the cylinder, which is an enormous pressure. So quite quickly, the pressure in here is going to build up again, and then the force, which is pressure times area, the area has stayed the same, we haven't changed anything. The pressure is rapidly increasing as it fills up from the cylinder, and then it's going to push back up on the diaphragm and then close it again, and then we start again. And in the process of closing that, it brings this plug back across here, disconnects this chamber from this one, and then we have our isolated chamber again, which the patient can take another breath, drop the pressure, reduce the force, the spring overcomes the force of the gas, pushes that plug down, opens up the gas to come back into this chamber, the pressure climbs again, pushes up on the diaphragm against the spring, closes the plug again, and it refills. So you've got a nice negative feedback system. Now the key part that makes this whole system work is while this very high pressure gas is flooding into this chamber, very quickly the pressure in here is going to start to rise, and because this gas here is working over such a big diaphragm area that we talked about earlier, the force applied to the diaphragm is going to rapidly increase, and very quickly it's going to overcome the force applied by the spring, and it's going to close this valve. So it will close this valve well before the pressure in this chamber reaches equilibrium with the pressure in this chamber and the cylinder. Now, the pressure being pushed back on this plunger here is going to be the same pressure as is being applied here, but it's a much smaller area, so the force is going to be much smaller, and therefore it won't be able to stop this plunger slamming shut across the orifice and preventing any more gas getting in. That's the key principle as to how the pressure reducing valve works. This massive area gives the gas a lot more force against the spring and allows this chamber to close itself shut and pull this plunger down well before this chamber reaches equilibrium with this one. So the pressure in this chamber is always much lower than here, and that's why it is a pressure reducing valve. And the final component that we need to add is the mouthpiece, and this is the bit that you see the patient holding that has the flush button on the back here. Now this is very simply a lever valve that when the patient draws air in, generates negative pressure in here, and that bends this diaphragm up and it moves up. It pushes this little lever, which then displaces it from this hole, and that opens the chamber into where the patient can breathe it from the mouthpiece, and that is how you can then on demand reduce the pressure in this chamber. This is just that extra little disposable mouthpiece. And likewise the flush button, to check it's working, you simply manually push with your finger on the end here, and that pushes the diaphragm up. It moves that little lever, opens up that little hole, and that's how you can safely take gas out of this chamber for the patient to breathe whenever they want. This bit's a pressure reducing valve, and this bit here is simply a demand valve. As the patient generates negative pressure by breathing in, it simply pulls that diaphragm, again big diaphragm, so not much pressure change needed for a significant force, pulls this up, lever moves, valve opens here and allows that chamber to empty. And that is the whole apparatus that you would need to know.